Einstein says the universe is like a bubble, and we live on the skin of that bubble, which is expanding. This is what we call the Big Bang theory. String theory, on the other hand, suggests there are other bubbles out there, forming a bubble bath of universes. Big bangs are happening continuously, meaning that there was something before the Big Bang. If you're asking whether this model is a Big Bang model with an initial emergence out of nothing followed by a collapse, the answer is no. The model does include a Big Bang, but the Big Bang wasn't the absolute beginning. Recently, scientists have discovered something strange about the universe. Images from the James Webb Space Telescope have revealed unusual findings that challenge our understanding of the universe, suggesting that something existed before the Big Bang. Scientists have long had a solid idea of how the universe evolved post-Big Bang, how the first stars, galaxies, and black holes formed, but the big question has always been, what existed before the Big Bang? These new findings have left scientists shocked because the telescope's data hint at gaps in our cosmological models. In the 1920s, astronomers studying distant galaxies discovered that most galaxies are moving away from us. Initially, some speculated that Earth might be at the center of the universe. However, further observations showed that while most galaxies are receding, some, like the Andromeda Galaxy, are moving toward us. Scientists eventually realized that it's not the galaxies themselves moving, but the space between them expanding. There's no central point in this expansion, so no matter where you are in the universe, everything seems to be moving away from you. The universe's expansion is not just happening, it's accelerating. This means that the farther a galaxy is, the faster it's moving away from us. Recent observations confirm that 97% of galaxies in the observable universe are moving away from us faster than the speed of light. But how is this possible, considering that nothing can travel faster than light? The key lies in Einstein's theory of special relativity, which states that nothing can move faster than light through space. However, the galaxies aren't moving through space. The space between them and us is expanding. This means they're being carried away by the expanding universe without breaking any cosmic speed limits. The expansion likely started with the Big Bang. Before the Big Bang, there was no space, no time, no matter as we know it. The Big Bang marks the birth of the universe and the beginning of space and time. We usually think of the Big Bang as the moment the universe exploded into existence, expanding from a tiny, hot point into the vast cosmos we see today. Around 14 billion years ago, everything in our observable universe, and even beyond, would have been compressed into a tiny point called a singularity. However, if the universe is infinite, it would have always been infinite. This means the Big Bang didn't happen at a single point but everywhere at once. The first galaxies formed everywhere, not in any particular spot. But the Big Bang doesn't explain everything, like why the universe appears the same in all directions or why it's so flat and spread out. If you look through a telescope, the universe looks roughly the same everywhere. This is where the theory of inflation comes in. Inflation suggests that just before the Big Bang, the universe went through a period of rapid expansion. In less than a trillionth of a second, it expanded from a tiny size to something much larger. This inflationary expansion was driven by a strange kind of energy present in empty space. This energy smoothed out any irregularities in space, making the universe appear flat when viewed on a large scale today. After this inflation ended, all the energy stored in space was released, heating everything up and triggering what we call the Big Bang. This explosion filled the universe with particles, light, and the building blocks for galaxies, stars, and planets. While inflation explains a lot, it raises new questions: what caused it to start and stop? And what was the mysterious energy driving it? New discoveries from the James Webb Telescope have raised even more questions. The telescope found that the universe is expanding at different rates in different directions. This is a big deal because scientists had believed that the expansion was uniform. The theory of cosmic inflation supports the idea that the expansion should be the same everywhere. But if these new findings are correct, they could challenge our understanding of inflation. Why is the universe expanding differently in different regions? Could there be something beyond dark energy influencing this uneven expansion? Dark energy is thought to drive the accelerated expansion of the universe, but the new discoveries suggest there might be more we don't understand. On top of this, the telescope has observed thousands of mysterious red dots in deep space. Initially, scientists thought these might be distant galaxies, but they're showing strange properties that don't match what we expect from early galaxies. These findings suggest there might be unknown types of objects that existed in the early universe, adding more mystery to what happened before the Big Bang. Some Nobel-winning scientists are now suggesting that our understanding of the universe may be missing a key piece. While the standard model of cosmology explains the universe's evolution from the Big Bang onward, it doesn't fully address what came before. The new observations are hinting that there's more to the story, something that happened in the cold, empty space before the universe expanded. These discoveries also challenge the traditional inflation theory, which states that a burst of rapid expansion, driven by vacuum energy, set the stage for the Big Bang. If the universe was shaped by this smooth, uniform inflation, why are we now seeing signs that the expansion is uneven? This suggests that something more complex might have been happening before the Big Bang, something we are only beginning to glimpse. The telescope has also detected strange objects in the early universe that don't fit into our existing models. These findings indicate that the early universe might have been more diverse and mysterious than we thought. All this evidence suggests that the Big Bang wasn't the absolute beginning but rather a transition from something else, something we don't yet fully understand. Scientists are increasingly open to the idea that our current theories may need significant revisions. The possibility of a pre-Big Bang era, where different forces or conditions shape the universe, could revolutionize our understanding of cosmology.